Hi everyone, if you've been following these videos in sequence, you've seen that we've now practiced several chi-squared analyses, however, all with only one variable. We'll get to the two-variable chi-squared in just a little bit here, but first we're going to do something that we can do as a follow-up to a single variable chi-square. You've seen that, of course, in our previous statistics, we always do some kind of measure of effect size or confidence intervals and things like that. Now, we can't do a lot of those things with the chi-squared, but I'll show you what we can do that sort of get us to some similar information at least, okay? Okay, so we've been working with this scenario. Again, if you've not been following this, this was what we did in the last problem. And I'm going to use this as our sort of backdrop for this example as well. So all we wanted to do here is we had some data from the current, or most recent, I should say, election, and we wanted to see if it was a different turnout by terms of party affiliation compared to the next most recent election. Now, in this case, these data are completely made up, and so just bear with me. Of course, this is all from one county in our little scenario. Okay, and here's what we saw. In other words, we expected to see this many Democrats, we expected to see this many Republicans, and this many other affiliations if our null hypothesis was true. In other words, if nothing had changed from the previous election, we expected to see those same frequencies of those parties. And however, this is what we actually saw, although again, this is made up data. Okay, now we already found a significant chi-squared statistic, and so that means that they weren't the same, right? We had changed the makeup since the previous time, okay? Now, normally at this point, we might calculate some measure of effect size of the independent variable's effect on the dependent variable. We might also do the confidence intervals, or we might do some kind of post hoc analysis if this were an ANOVA. But of course, we can't do that in this kind of instance. Because we had only one variable and it had three levels in this case, all we were doing was trying to see if those levels appear with different frequencies than we expected to see. And we found out that they did. Now that's certainly interesting, but now we can't do any kind of measure of effect size because there was no independent variable. There was also no dependent variable. This was just a variable, and we have no insight now on what caused these differences. We can start to theorize for sure, but we have no way of actually telling because we measured only one variable. And so without the ability to do the effect size, there are some interesting things that we can do that'll help to get us a little bit more information about these patterns and to say things like, was this meaningfully different than what we expected to see among this particular group? Or, for example, in the last video I said, now did the Democrat turnout really make any kind of impact on this chi-squared analysis? That's what we can do now, and I'll show you how to do that. Now, one of the first things we did, and I walked through this very briefly in the previous video, is we could just look at the biggest discrepancies that we found between what we expected and didn't expect. So that's already built into our math. We just get to this point in the chi-squared analysis, right? We've already taken the differences, we've squared those differences, then we divide those differences by the expected cell frequency, and we get to this point before we add it all up. So this is just the penultimate step in our chi-squared equation. And what we can do is look at all of these digits, and we see that the biggest one, of course, is this third one. 249.36 is larger than any of these other ones. It's actually very close to this one, however. Now, all this means is that this last group, that third group or that third cell, made the biggest difference in our chi-squared analysis. Or in other words, it was the biggest contributor to our chi-squared statistic, and it was the most unexpected or the least expected outcome that we saw, or the biggest difference between what we expected and what we actually observed, okay? And that, of course, was the third cell. The third cell corresponded to the people who were of an other affiliation, meaning it wasn't the Democrats or the Republicans. And in fact, as we saw in the last video, they turned out with a higher frequency than we expected. Okay, so that's pretty interesting because you could say that they made the biggest difference in our chi-squared analysis. However, I would also look at this and say, well, wow, but 216, that's very large also, especially compared to this. And so the 216, of course, corresponds to the Republicans. It's not very much different from the others. And so I would also say there's a large turnout from the Republicans. Now, let me point out really quickly, I say it was a larger turnout than expected because if you look at our table, as we had on the previous slide, or at the beginning of the video, I suppose I should say, it was higher than expected, okay? The Democrats, of course, were just a little bit lower than expected, but we don't know if that was a meaningful contributor yet. But I'll get to that in just a minute. Okay, so let's see what else we can do here. Okay, so although we can't calculate an effect size, we can do something kind of similar to that. It's called a standardized residual. This is a statistic that gives us an idea of whether an individual cell contributed significantly to the chi-squared statistic. In other words, it's kind of like saying, well, how much of the chi-squared value is attributable to just the cell difference that we saw in this particular cell between what we expected and what we actually saw. Okay, so it's called a standardized residual. And all we do is take this equation and apply it to each individual cell. And then for each cell, we come up with a standardized residual. So in some ways, it's a little bit like, was this particular cell a major contributor to the chi-squared value? Okay. So as you can see here, we're just going to take the observed cell frequency for each individual cell, subtract the expected cell frequency from it, and now we're going to divide that by the square root of the expected cell frequency. Okay, so it's not very difficult. We already have all of these values, of course, except for the square root of this. And so the math's quite straightforward. I'll show you how to do that for each individual cell here. Now, the way that we tell whether it was a significant contributor or not is if the absolute value of the resulting R, or standardized residual, is equal to or greater than 2, we can then say, yes, this was a significant contributor to the chi-squared value. So let me show you how to do that really quickly. It's not very difficult. So let's now see how to do this for the first cell. The first cell, of course, corresponds to the Democrats. And all we do here is we take the observed cell frequency, which of course was 3,258. So that's going to go right there, the first thing in the equation. We then subtract the expected cell frequency, which of course is right here, 3,295.95. Then we're going to divide that difference by the square root of the expected cell frequency, which goes right there. So of course, the difference between the expected and observed was negative 37.95. In this case, the sign doesn't matter because we're looking at the absolute value. However, we'll continue to carry that out. The square root of 3,295.95 is, of course, 57.41. And then, of course, we simply divide to find a standardized residual of negative 0.66. Now, right here, of course, the negative sign doesn't matter. We're just interested in the absolute value. 0.66 is, of course, much smaller than 2, and so therefore this particular cell was not a major contributor to the chi-squared analysis. Okay, and so it looks like the Democrats didn't actually make any impact on this chi-squared value at all. Okay, let's now try it for the Republicans. So take a look here, and again, these data are all made up. Same thing here, we're just taking 3,182, which was the observed cell frequency. We subtract the expected cell frequency, then divide by the square root of the expected cell frequency. Of course, the difference between the observed and expected is 729.2, and the square root of 2,452.8 is 49.53. And we divide that and get 14.72. Now here, 14.72 is much larger than 2, so therefore this cell was a major contributor to the chi-squared analysis, the chi-squared statistic, I should say. So therefore, they seem to have made a big difference here in whether or not this was a statistically significant difference between what we expected and observed. So I could say here, it looks like the Republican turnout was important for our statistical analysis here. All right, we'll do it one more time for the other affiliations. And here we go. We've got the observed cell frequency was 1,225, expected was 1,916.25, and we do that. The difference, of course, was negative 691.25, and the square root of 1,916.25 is 43.77. We, of course, divide, and again, we can ignore the sign here. The point is 15.79, of course, is much larger than 2, therefore this was a major contributor also. Now we knew this, of course, well, we knew that this was the most important difference, or the largest difference, because that's what we saw in that earlier slide when we saw that it was the biggest discrepancy score, it had the biggest discrepancy score. And now we can also say that this was a major contributor to the chi-squared analysis value overall. Now, what's interesting here also, if you take every standardized residual that you calculate for the entire chi-squared, you then square them and add them up, you should find that it equals your chi-squared value. That's just a nice little trick that you can do to double check your math for one thing, but then also to, well, I mean, I guess that's basically it, but it also shows how these numbers all work together. Anyway, so now what can we do with all of this information together? Okay, so when we had the statistically significant chi-squared value, we already knew that what we saw actually differed meaningfully from what we expected to see if the null hypothesis were true. And our null hypothesis was that we were going to see Democrats and Republicans and other affiliations in the same proportions as we saw in the previous election in this election. So of course now we can say that was not true. Now, if we want to go back and say, well, what made the big difference? It's clear that the other voters, or the voters of other affiliations, were the ones who made the biggest difference in our chi-squared analysis. That's pretty important, especially if you're interested in the election. Maybe you start to tell people, well, hey, if we really want this election to, if we really want to make a difference in this election, maybe the unaffiliated or other affiliated voters are the ones to reach out to. Of course, that's not the entire point, however, because it turns out that in this case, the Republican turnout made an enormous difference because it was also a major contributor. There were more Republicans overall than there were of the others. But of course, in changing the expectations from the previous election, the Republicans made a big difference also, not as big a difference in that in the discrepancy from the expectation as the other affiliated voters, but they still made a major difference there. And we can also say that it looks like the Democrats in this case didn't change enough from the previous election to actually say that there was a major difference here, or that they made any major contribution to the unusualness of the chi-squared value there. Okay, and that's kind of how that works. Okay. Now, of course, we can do some other things for the two variable chi-squared analyses, but first I'm going to walk you through how we do that. So I will do that in the next video. You'll see a two variable chi-squared analysis. I'll show you what to do there. I'll see you then. Bye.